Greetings to everyone. My name is Suman Analaki Ramesh, metric number TG223, and today I will be presenting abstract for Lab 5. The objective of this experiment is to determine the limiting reactant in a mixture of two soluble salts and also to determine the percent compositions of each substance in the mixture. During a chemical reaction, a limiting reactant is a reagent that is fully absorbed. The reaction will come to a halt until its reagent has been processed. The reactant that remains after the limiting reagent has been absorbed is known as an excess reagent. The limiting reagent determines the overall potential yield of a chemical reaction so that the one that yields the least volume of substance is the limiting reagent.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zati Zawani binti Muhammad Rasti and my ID is TG20041. I'm from group 4. Okay, I will present about methodology. A. Precipitation of Pa3PO4 2 from the salt mixture. First, measure 1 gram of Na3PO4.12H2O and BaCl2.2H2O and transfer the mixture to a level 400 ml beaker and add 200 ml of deionized water. Stir the mixture with stirring rod for 1 minute and allow precipitate to settle. Leave the stirring rod in the beaker. Second, cover the beaker with a watch glass and warm the solution 80 until 90 Celsius with a slow flame for 30 minutes. After that, remove the heat and allow the precipitate to settle. Third, once the precipitate has settled, carefully decant to 50 ml volumes of the supernatant into separate beaker 100 ml. Label beaker 1 and beaker 2. Save for part B. Okay, fourth, wet a filter paper and use it to filter the remaining warm solution. Fifth, remove the filter paper and precipitate from the funnel and transfer it on a watch glass. Place the filter paper and watch glass in an oven overnight. Last, for part A, weight the dry precipitate on the filter paper and determine the weight of precipitate. In part B, determination of limiting reactant. Test for excess PO43. Okay. Add 2 drops of the test reagent 0.5 m BaCl2 to the 50 ml of the supernatant liquid in beaker 1. If a precipitate forms, the PO43 negative is in excess and Ba2 plus is the limiting reactant in the original salt mixture. For test, second we do a test for excess Ba2 plus. Add 2 drops of the test reagent 0.5 m Na3PO4 to the 500 ml of the supernatant liquid in beaker 2. If a precipitate form, the Ba2 plus is in excess and PO43 minus is the limiting reactant in the original salt mixture. Okay, now I want to present about result. Precipitation of Ba3PO42 from the salt mixture. Mass filter paper we get 1.035 gram and mass filter paper plus precipitate we get 1.852 gram. And how we can get a mass precipitate? We do a mass of filter paper plus precipitate minus mass filter paper like this 1.852 gram minus 1.035 gram and we get 0.817 gram. Okay, and Our result is determination of limiting reactant. In beaker 1, we get a precipitate, yes, and because it's a yes, and this limiting reactant is Ba2 plus, and excess reactant is PO43 minus. In beaker 2, we don't have a precipitate, and limiting reactant is Ba2 plus and excess reactant PO43 minus. Okay, I want to explain about this result. In beaker 1, a precipitate was present after mixing 0.5 m BaCl2 with 50 milliliter of supernatant liquid. So this shows the PO43 minus is in excess and Ba2 plus is the limiting reactant in the original salt mixture. While in beaker 2, no precipitate occurred, so this shows the PO43 minus is in excess and Ba2 plus in the original salt mixture too. Thank you.
Good day. I am Kabilan Analalaki Tangadurai, matrix number TG20050. Would like to present the discussion of experiment 5 chemistry, which is limiting reactant. For experiment part A, which is precipitation of Ba3PO42, which is barium phosphate, from the salt mixer. Based on the result, the mass of filter paper is 1.035 gram. Mass of filter paper plus precipitate is 1.852 gram, and the mass of precipitate is 0.817 gram. Ba3PO42 is barium phosphate. Ba2 plus is called barium, and PO43 minus is phosphate. So for experiment part B, which is determination of limiting reactant, precipitation occurs in beaker 1. This shows that PO43 minus, which is phosphate, is in excess reactant, and barium Ba2 plus is the limiting reactant. In beaker 1, only some of the original PO43 minus, which is phosphate, remains because all the barium has finished reacted in the part A to form barium phosphate. When the test reagent 0.5 m BaCl2 is added to the supernatant liquid in beaker 1, the barium from the test reagent react with the remaining phosphate in the supernatant liquid to barium phosphate, from which is a precipitation. Thus, a smaller amount of barium phosphate is produced when barium off is reacted. At the end of the reaction, only the product barium phosphate and some of the original phosphate remains. For this reason, we say that phosphate is excess reactant and barium is the limiting reactant because it limits the amount of the product that can be obtained. Now, I want to explain the exercise that is in Lab 5, limiting reactant. The question in the exercise is 1.146 gram of mixture of the solid salt Na2SO4, which is sodium sulfate, and PbNO3 2, which is lead nitrate, forms an aqueous solution with the precipitate of PbSO4. PbSO4 is lead sulfate. The precipitate was filtered and dried, and its mass was determined to be 0.672 gram. The limiting reactant was determined to be Na2SO4. So, The first question is write the molecular form for the equation for the reactant. So the answer will be from the question Na2SO4 plus PbNO32 is also from the question. So we will get PbSO4 plus 2NaNO3. So at the bracket S, which means compound is a solid. So lead sulfate is a solid and AQ is a compound that is dissolved in water. So sodium nitrate is dissolved in water. So we write here AQ and here S. The second question is write the net ionic equation for the reactant. So the net ionic equation is Pb2 plus SO4 2 minus. So we will get PbSO4 because Pb here plus 2 here minus 2. So we will get PbSO4. We write here S because it is a solid, which is lead sulfate. The question 3 in the lab 5 is how many moles and grams of Na2SO4 are in the reaction? So the mass of precipitate is 0.672 gram, which is already stated in that question. So the mole of PbSO4, we can use this formula to get the moles of PbSO4, which is lead sulfate. So mass of PbSO4, which already given in the question, over with molar mass of PbSO4, which we can find by using periodic table. So molar mass of lead sulfate is 303.26 gram per mole. So we will get 0.0022 mole or similar 2.22 times 10 to the power 3. So the number of moles of Na2SO4 is equal to the number of moles of PbSO4. So the mole ratio between PbSO4 and NO2SO4 is 1 nisba 1. Then mole of Na2SO4, which is 0.0022 mole PbSO4 times 1 mole over Na2SO4 over 1 mole PbSO4. So we will get the same answer, which is 2.22 times 10 to the power negative 3, because the moles of Na2SO4 is equal to the mole of PbSO4. So we will get the same answer for both. Then the mass of Na4SO2 is mole Na2SO4 times with molar mass of Na2SO4. So the molar mass we can get from periodic table, which is 142.04 gram per mole, and the mole of Na2SO4 we get here 0.2222. So when we times, we will get 0.315 gram. So this question asks how many moles and grams. So number of moles of Na2SO4 is 2.22 times 10 to the power 3, and mass of Na2SO4 is 0.315 gram. The last question is what is the percent by mass of each salt in the mixer? So the mole ratio between PbSO4, which is lead sulfate, and lead nitrate is 1 nisba 1. So moles of PbNO32 is equals to 0.00222 mole PbSO4 times with 1 mole lead nitrate over 1 mole lead sulfate. So we will get mole of lead sulfate is 0.00222. And then we need to find the mass of lead sulfate. So the mass of lead sulfate is equal to 1.146 gram minus 0.315 gram. The 1.146 gram is already in the question, and 0.315 we get from the previous question, mass of Na2SO4. So when we minus these both, we will get the mass of lead sulfate, which is PbNO32, is 0.831 gram. So finally, to calculate the percentage by mass of sodium nitrate, we have to use the formula of mass of sodium sulfate over mass of mixture times by 100 because the percentage is 100. So when we calculate, we will get 0.315 gram, which is the mass of sodium sulfate over with mass of mixture 1.146 gram, which already given in the question, times by 100. So we will get the answer 27.5% for the sodium sulfate. And the percentage by mass of PbNO32, which is lead nitrate, we also use the same formula like previous. So mass of lead nitrate over with mass of mixture times by 100. So the mass of PbNO32, which is lead nitrate, is 0.831 gram over with mass of mixture that's already given in the question, 1.146 gram times by 100. So we will get the answer 72.5% for lead nitrate. Thank you.
Assalamualaikum dan salam sejahtera. My name is Nofarhana binti Zulkifli. ID student TG2006. I want to share my conclusion and recommendation. So, the result that will be obtained in this limiting reactant. The limiting reactant that to determine the limiting reactant in a mixture of two soluble salt and to determine the percent composition of each substance in the mixture. As we saw the experiment, there are many different ways to determine the limiting reactant, but they all involve using moles in the balancer chemical equation. The amount of product that can be formed based on the limiting reactant is called the theoretical yield. In reality, the amount of product actually collected, known as the actual yield, is almost always smaller than the theoretical yield. The actual yield is usually expressed as a percent yield, which specifies what percentage of the theoretical yield was obtained. To determine which reactant is the limiting reactant, first determine how much product each reactant would form if all reactants were consumed. The reactant that form the least amount of product will be the limiting reactant. Calculate the result of each reactant. To review, follow the strategies outlined in how to calculate theoretical result. That's all. Thank you.